So yeah, just wanted to briefly introduce us. I'm Tyler. I'm one of the co-founders of Memfault, and I currently lead the developer experience team. Been a firmware engineer for about, I guess, 10 years now, getting my start at a company called Pebble. We made smartwatches, one of the first smartwatches that was created. Very fun little product. I wrote a whole bunch of firmware code for everything on a Cortex M3 with a pretty crappy e-paper display. And these devices tried to last about 7 to 10 days sometimes. Then I worked at Fitbit for a while, and I just kept getting into developer tools and writing, honestly, web applications and other tools that kind of firmware engineers were using. Fitbit had between 50 and 150 firmware engineers, and so there was a lot of efficiency gains to be made by building really nice developer tools that would allow them to debug their issues more quickly. I'm excited to have today with us Dave Webster from Latch, who is an engineering manager there. Latch has been a customer of Memfault for, I would think, probably over 3 years now. They have used Memfault to great success in helping them kind of debug issues in the field and proactively reach out to customers if they have any issues. But I will let Dave introduce himself. Go for it, Dave.
Hey everyone, I'm Dave Webster, engineering manager here at Latch. I've been building a variety of commercial, industrial, and consumer IoT products for over 10 years. I actually had a little bit of exposure to Memfault prior to coming to Latch. So when I came here to Latch, I was really excited to see that they were already using Memfault and the variety of tools that they provide. And while my focus at Latch is on our internet-connected devices, I'm really looking forward to telling you all about how we use Memfault in both our internet-connected and non-internet connected devices alike. So really looking forward to it, and thanks for having me.
Sweet, thanks, Dave. Okay, so a few things about the agenda. I'll be going over kind of what is Memfault, what does Memfault specialize in, why did we build it, honestly, and then just giving an overview of how Latch may use it, and then Dave will get into actually how Latch uses Memfault, how they set things up, what they've gained from it, and kind of what they're excited about going forward with Memfault. And then towards the very end, we'll have a Q&A, where again, if you click the Q&A button, you can feel free to ask questions. We will try to answer them to the best of our ability on the fly. So first things first, this kind of sets the stage for kind of how we talk during the webinar, what we focus on, and honestly, just generally curious. And so we have a poll. So the main question I have is, for those at your company that are not building firmware, these are app developers or these are cloud developers, do they have an observability solution in-house? This is whether they use Google Crashlytics or Bugsnag or Sentry and New Relic. All of these sorts of things are app monitoring tools and cloud monitoring tools. So we're curious if they have them. I was always jealous. I was very jealous during my time at Pebble when they had amazing mobile monitoring tools. I'll leave it open for about 10, 15 more seconds to give people some more time. All right, let me end the poll here. So the answers that came in is, so they have about half of you guys said, or half of you said that there's the team, that they have in-house observability. 10% said they do not have observability. 25% said there's no team doing app or cloud development. That's actually kind of shocking in today's kind of firmware and hardware world. And a little bit of you said you don't actually know, which is fine. And I have another question. So this is more specific to Memfault and kind of our topic today is, do you have observability for your embedded devices as Latch does? This is, can you capture some sort of metrics from your devices in the field? Can you debug a crash that is happening on the device across the world? That sort of thing. Are you capturing logs? All the things that we dream of and that I dreamed of. Dave, you've been in the business for 12 years. Could you answer this 12 years as yes, and it's sophisticated?
I wish I could. Too many of those 12 years were B or C.
Got it. Okay, I'm going to end the poll now, and then I'll report back the responses here. So yeah, so 12% said yes, and it's sophisticated. Awesome. I'm very happy to hear that, actually. About half said yes, it's limited, and about 30% said we do not have anything. And so we have some content for you. All right, let's move along. So what I'd like to talk to you about today is, where does Memfault fit into hardware observability? And again, why did we build it? And why do we feel like it's very important? So when you're talking about cloud systems and mobile applications, and what happens when all of those crash, generally the tools are pretty good, and they've been kind of in development for a very long time, I would say. People get alerted. You have PagerDuty, which is an entire system built upon being alerted when either a server or a website or a mobile application goes down and it starts experiencing issues. In my mind, you can actually almost get too much data from these systems. People are being flooded with logs and honestly paying a lot for it, for something that they may just need a little bit of signal about, whether it's like up or down. And when you have these systems in place, alerts, people that are literally hired as SREs to basically, it's their job to monitor dashboards, you can probably fix these issues before your customers notice and get them fixed very quickly. But honestly, like in our world, building hardware, building firmware, shipping these customer devices to customers, what happens when your device crashes? Honestly, we typically don't even know that it's crashing. I have talked to so many firmware engineers, and I have asked them, how often do your devices crash? Do you know how often they're crashing? And the answer is typically, I have no idea. We don't think it crashes in the field. And we've proven that time and time again to be incorrect. They almost always do at some point, basically. They eventually run out of heap or RAM. They eventually have a hardware bug that causes a crash or an assert. And you just need to figure out kind of why. But when your device crashes in the field, you don't know until your customers report it. I know we at Pebble, we had we would always monitor Reddit to make sure that there were no bad firmware updates. So we'd basically, for the next day or two, always monitor Reddit to see if there were any issues that cropped up, which was it was fun, but also very nerve-wracking. And yeah, we relied on our customers way too much to debug our products for us. They were basically our way to debug in production for a while until we built a lot of these systems. But hardware should just work, right? Like in Latch's case, it's a lock. It should work perfectly. And hardware typically has. We've had these locks on our doors for years and years and years, and they do work. They have a key. You turn it and it opens. And if it doesn't work, you may just have to lubricate it a little bit, and then it should work again. But what about software? It's a totally different ballgame when you combine hardware and software, especially in the IoT world. And with hardware, if you get it right, it's going to be generally fine. But also there are some issues. It can have manufacturing defects. Hardware can wear out. It can rust. It is exposed to the elements, and that is rain, moisture, weather conditions. I know at Pebble we would, actually, this is probably a huge issue for Latch, I would say, but I'll let Dave. Actually, Dave, can you speak a little bit about how hardware or software may fail in the field? Just a little bit, yeah.
Yeah, absolutely. I mean, I think the hardware piece is really tricky because, you always have that question, is it hardware, is it firmware, right? We've had issues where literally slamming the door too hard jiggles the batteries, right? And, we see a lot of power on resets or something like that. And, you may get a report from a customer, lock doesn't work, right? That's about it. So, you're kind of flying blind without the right level of observability in your platform.
You're thankful that the customer reported that bug, but it's probably the worst bug report you've got. It doesn't work.
Exactly.
Yeah, so hardware itself is super hard to debug and also to fix. It usually means replacing the lock itself. But oftentimes, like the lock doesn't work, or maybe the watch doesn't work, or the step tracking doesn't work. It's oftentimes a software bug. software is generally relatively, or comparatively to hardware, pretty easy to fix. You can ship a firmware update and the bug can be fixed. You can write in various different languages that can reduce your likelihood of bugs in the future. It's not going to be as hard as basically building hardware every single time. And with software, it's generally reliable. Nothing wears out. If it works once, it'll almost always work again, unless there is, I guess, some other task corrupting memory, which will affect something. But typically, if software works, it will work continuously. Memfault's job and what our goal is to make software the most reliable part of the Internet of Things. Hardware is proven pretty reliable, and software, I think, is proven to be not so reliable. I was making the joke earlier. In my kitchen, I think my smart lights got updated about basically last week, and they've been turning on and off randomly throughout the last week, and I cannot be bothered more by chopping an onion and then the lights flicker, and it's just annoying. Anyways, our job is to basically solve and prevent a lot of these software issues from happening, and making software as reliable as hardware. First things first, and this is, I think, a rule that I have always typically operated by, but especially now, is the software itself will never be perfect. Especially in today's world, we have software and hardware that interacts with many, many other pieces of hardware and software, especially with Latch. Like, their devices connect over connectivity, whether that's Wi-Fi or Bluetooth, or to mobile phones. The Pebble Watch connected over mobile to Bluetooth to mobile phones, and many mobile phones, and we can never actually fix all of the bugs that our product and our users kind of experience. And also, developers will ship bugs. Jack Ansel is kind of one of the primary people in the firmware space. And he did a study, basically. The top 1% of developers will ship 11 defects per 1,000 lines of code. I've talked to a few people who think that they never write a bug, and that is just not true. You will ship bugs. The product will experience some issues, no matter how hard you try. And so in that case, you need to get a process in place to be able to ship out these firmware updates that you have for your IoT devices, fix the issues in the field, I guess debug them first, find the fix, and then ship them in the field, and continue this cycle. This is mostly a virtuous cycle. At Pebble, we would ship firmware updates pretty much every month, like clockwork. I think for our devices, we basically shipped 30 firmware updates over the lifespan of the device, which I would say is a lot for a hardware company. But we loved the software side of things, and our hardware was basically powerful enough to where we could just keep shipping these firmware updates. And this is how you make better experiences for your customers in today's IoT world. They're buying the ecosystem. They're buying the hardware plus software, not just the hardware. And so Memfault, how are we thinking about this exact wheel? How do you detect issues in the field, fix them, and then deploy them? First, you just have to identify them. The first step to solving any sort of crashing issues in the field is understanding whether these devices are crashing. And so Memfault's kind of bread and butter is detecting these crashes in the field by hooking into fault handlers, or by capturing exceptions, or by parsing logs, and understanding, are these devices crashing? How often? How many devices are impacted? How many customers are actually impacted? And then prioritizing those issues based on those counts. Is it just my CEO's device that is crashing, or is it all of our customers' devices that are crashing due to a firmware update? You need to be able to determine which one is which, because maybe the CEOs or the CTOs device crashing is maybe not the highest priority. That was always a frustrating point of my previous jobs. I had no dashboard to point to that says this is not an important bug. Once you know you have a bug, or once you know you have a crash, being able to diagnose this. And so what we're seeing here is this is the Memfault view for looking at a particular crash that has happened in the field. Could have happened anywhere in the world. The crash kind of captures a core dump, which is a collection of memory and RAM, sends that back to Memfault. We parse it. We give you stack traces, and kind of paint a picture of exactly what happened running in firmware at the time of the crash, so that you can very easily fix these bugs. There have been many times where I tried to reproduce a bug many times, And I will eventually, basically once we built once we built core dump infrastructure, very similar to this, I was able to basically fix the bug in under an hour because it tells me exactly where the bug is. Dave, I'll steal your words, flying blind. Like if you don't have the ability to view a lot of this information from a core dump, it feels like flying blind. And so saving time, saving your precious resources, whether that is the engineering team or you yourself as an engineer, your sanity, trying to reproduce a bug, there's a lot of ways to save time. And it's not just the crash itself that is important. Oftentimes it is what leads up to the crash or kind of the state of the device as hardware wears out. And honestly, as the, I guess, interaction between the hardware and software wears out and things start becoming buggy, you can sort of predict when things will happen and you can help paint a picture. The accelerometer on some of these, watches that we were working on would wear out, or flash would become really, really slow to write to. And we would have various different bugs kind of exacerbate by just the fact that these flash chips are becoming super slow. If the device is in the field for 2 years, it will exhibit very different bugs than if the device is basically coming right off the production line. And honestly, you have to fix all the bugs because your devices are still going to be in the field and people still expect to be able to use them properly. So Memfault's going to try to collect as many metrics as possible from these devices to help paint a picture, whether that is current battery life, how often the device is connected actually to a mobile phone or to its gateway, how many bytes are being sent over the network radio, how long the CPU is active, how long it's being spent writing, erasing, reading from flash. All these sorts of things can help paint a picture. And finally, one of the other things in Memfault that pertain to, I think, Latch's story is getting the visibility to all of the devices in the field and their current metrics. How quickly is the battery being depleted? How many times did the product successfully work when there was an attempt taken, and how many times did it actually succeed on that attempt? Getting that sort of measurement, it's a very simple KPI, successes over attempts, and making sure that it is as high as possible, if not perfect, is something you need to know, and especially from release to release. If you ship a new firmware update, 2.0, and you're trying to go from 1.0, you need to ensure that nothing has regressed, and if anything, it's gotten better over time. So as firmware engineers, I very rarely ever looked at dashboards, but now I look at them all the time, and I know that we are trying to convince firmware engineers that actually a lot of their job is looking at a dashboard here and there about core metrics that they're actually trying to track, whether that is higher level system performance or even their little thing. I was tasked oftentimes with like improving that flash write speed or erase speed, but I need to know, like, is that actually getting better over time? And that was one of the queries I would write for our data warehouse was, are we spending less time writing to flash? And if so, great, I did my job. And so depending on who you are here, I think there's a little bit of a Memfault story for everyone at the company, whether you are an engineer like I was, whether you are a product manager who kind of owns the product and the success of the product, or the head of engineering where you kind of own the engineering team and their success. As an embedded engineer, it's what should I be working on and what are my top priorities? Did I make a change and did it get better or did it get worse? Product managers tracking, are the customers happy? And are there ways to improve the product over time? And are there things that are particular pain points? Head of engineering is going to be looking at, are my engineers spending their time wisely? Are we prioritizing enough or the right issues? Is that crash that we're working on only happening on the CEO's device, or is it happening on all of our customers' devices? And is that the right issue to be working on? Memfault can kind of help paint a picture for all of this. And we spent a lot of time thinking about kind of how this plays in, where customers are today, and where we want to get customers to, or I would say firmware engineering organizations. Oftentimes they're in the reactive. They have very little visibility into what's going on. I ask people how often their devices are crashing. They either say they don't crash or they don't actually know, and that is the reactive. We want people to be able to say, I know how often they're crashing. they're crashing this many times, this many customers are impacted, we're getting this better with each release. And that is becoming proactive and very strategic. They know exactly, what is happening on their devices, and they know how they can get better. With Memfault, we're kind of the blue color. If you have Memfault, you go from pretty much the gray color to the blue color with very little effort, which is one of my favorite things, actually. All of this data is really hard to gather, right? My devices are constrained. It's very difficult. How can I possibly gather logs? How can I possibly gather, write some JSON or construct JSON? Doesn't matter. We've actually built a system that works on these very constrained systems. If you have 64K of RAM, great. That's more than enough. We will happily work on that infrastructure. Our core dumps are just a few K. The metrics is super optimized to be able to be used with even the most constrained devices. We also work with Android and Linux. There's pretty much no device we can't work with unless you are running 16-bit or before. I guess there is a limit. But we will work with your setup for the most part. And I believe the three most difficult things for people to diagnose remotely, and people are using to great success with Memfault, is power issues. Is battery life getting worse or getting better? Connectivity. Am I still connecting to the phones that existed 10 years ago? And am I going to be able to connect to the phones that are coming out in the next 5 years, or Wi-Fi routers or gateways or connectivity systems? And then also, are my devices just working correctly? Are they computing the right thing? Are they hitting heap issues? Are they pinned at 100% CPU? All these sorts of things we'd like to help you solve and figure out. So now I'm going to pass it over to Dave. And Dave, I will drive the slides, but I'll try to keep with you. And Dave is going to talk about how Latch builds reliable products using Memfault.
Great, thanks, Tyler. Hey, everyone. Thanks again for being here today. And thank you to the Memfault team for hosting me. I'm really excited to tell you all about how Latch has used Memfault to build reliable products. So first, I'll tell you a little bit about Latch. For those of you who aren't familiar, at Latch, we make spaces better places to live, work, and visit. That's kind of how we think of the value we're providing to our customers. So we have a suite of software and hardware offerings that allow our customers to easily enable flexible and secure smart access to their buildings, regardless of the available connectivity. You can go ahead. And so our core set of products, which is what I'll be focusing on during the webinar, provide that smart access to common and private spaces. Think about kind of apartments or common use spaces at commercial buildings via a variety of smart locks. We have quite a number of smart locks. As you can imagine, ensuring this access is secure and reliable is critical to our customers and end users. Tyler kind of hit on this a little bit earlier, talking about hardware. We kind of always like to think about it. A physical key has zero downtime, right? There's no downtime on a physical key. So we have a very high benchmark for comparison with our products. And this is really where Memfault comes in. This platform helps us proactively monitor both our internal and external fleets of devices during all stages of development and through to production, so that we can provide that reliability that our customers expect. So first, I want to talk a little bit about where we are at currently with our Memfault integration and usage, and then I'll dive a little bit deeper into how we got here and where we are at now, and how we continuously leverage the platform to maintain and improve the reliability of our products. So we currently have tens of thousands of devices installed with Memfault integrated. And just to highlight kind of the flexibility of the platform, our suite of devices leverage different methods of connectivity. So like I mentioned earlier, right, we have some devices that are directly connected to the internet via Wi-Fi or Ethernet that are able to directly push this data to the cloud and onto Memfault. But we also have many devices that connect to mobile apps via BLE that push the data through to our own infrastructure and then onto Memfault. Also, we have different devices. Some are battery powered and some are hardwired. So we measure different metrics across those different products. Additionally, it's really important to note that while we have shipped some products from the get-go with Memfault enabled, it is also very easy, and we've done this on some of our older products that have been in the field for years, to upgrade those products in the field to add this valuable observability through Memfault. Our devices are also leveraging pretty much every capability that Tyler talked about already that the Memfault platform has to offer, ranging from the core capabilities such as traces, core dumps, heartbeat metrics, to a little bit more sophisticated capabilities such as compact logging and custom data recordings, which I'll touch on a little bit later.
I was so excited when you guys were like, we want to backport Memfault to the old devices. That was awesome. Remember that?
Yeah, it was really exciting, to do that. We certainly, we were kind of in, like the poll said, we were kind of in that B or C range. So to be able to see that leap on a product that we had was really exciting. So how do we get where we are today, and how do we continue to leverage the platform in our day-to-day efforts? So kind of Tyler started to bring this up. As I mentioned, we've had products that we've both shipped from the get-go as well as ones we've upgraded. For the ones that we've upgraded and we previously shipped without the Memfault observability, we had some limited observability, whether it was text or binary logs that got uploaded into our ecosystem that we may, parse through manually and do some limited analysis on, or whether it was UART logs that we recorded during our testing. We really were living in that reactive stage of development maturity. And I'm sure many of you have experienced, this level of manual debugging and analysis is very inefficient and slow, right? You spend a lot of time on that, where you could be spending your time in better areas developing features that will impact your customers more directly. And since adopting Memfault as our go-to firmware observability solution, we really have made that Memfault a first-class citizen in our design and development process. And this is what has progressed us into that proactive, strategic, and transformative stage of maturity in development. And so, like I said, we use Memfault throughout all stages of our development, from the beginning design of a new feature, where we always are analyzing that feature for opportunities to add traces and metrics, so that as soon as we release that feature to our customers, we immediately can get feedback on its impact to the customers, as well as things like the performance at scale, right? You can do a certain level of testing internally on features, but you really don't know until you get it out at scale. And Memfault allows us to see that performance there. As well as during the testing phases, we can easily diagnose and debug the issues either prior to ever handing off a release to QA or during QA. One of the things that really helps us is, as more and more companies build globally distributed teams, Memfault provides a streamlined process for sharing as much context as possible across those teams when issues arise during internal testing. So there's no more slacking or emailing text logs or asking QA, what were you doing on Tuesday at 10:35 a.m. when this issue occurred? And also no more, oh no, I forgot to turn on my serial logging for a week-long automated test, and use all that context. So really, Memfault allows us to consistently capture that context and information to quickly debug issues. And so obviously this alone moves the discovery and resolution of these issues left in your development process, which saves engineering a lot of time and money prior to ever even releasing firmware. But as we progress that firmware through to production, we continuously want to monitor all the data coming from our fleet. So this is where we hold weekly or bi-weekly meetings, which we call our Memfault data review, which I'll go into in detail here.
I love the QA usage. Like, having Memfault, it's not just about production devices. It's probably about even developer devices, your own test devices. Having all the QA ones hooked with the Memfault, even if there is a bug. So many times, I guess at Pebble as well, there would be like, oh, there was a bug, but it fixed itself. Like, no need to look into this issue anymore. It just, like, the screen blipped for a moment and it's like an absolute crash. And then we ship it, and then the customers are like, it's crashing all the time. But if it happens once in QA, it's going to happen a lot in production.
Exactly, right. Often you won't even catch a crash in QA, right? It may happen, over a few days, and, the device reset and everything kind of looks fine, right? And you never even noticed it, right? Whereas, you immediately get an email now, right? The crash occurred, right? So you're able to proactively address these issues much quicker.
It's awesome. Cool.
So yeah, Latch holds what we call our Memfault data review. And so this is kind of a dedicated continuing effort where we proactively monitor and analyze both internal and external fleets for potential performance and reliability issues. And so with the fleet dashboard, we are easily able to monitor things such as trends in installation and firmware adoption rates, this is something that helps our product team make informed decisions. It may not be a direct firmware metric, but it's something that can allow our product teams to understand how our fleet is growing, how users are adopting new firmware, and we can drive change in that way from a product perspective. And so we can also monitor things such as firmware issues. This is where many of you may be even more interested. We can see trends in the traces that we receive over time. Is there a big uptake? Are we seeing more resets? In particular, right, we may look after a new release. Are we seeing a lot of new issues? And so, right, I want to just point out, right, you can see here, this is our real dashboard for one of our products, and we have very few new issues here, right? But the nice thing is in the example of we release a new piece of firmware, customer started upgrading, we might notice those new issues before a customer ever notices or reports that issue. And we're able to have that fix ready. So when that customer does come in and report the issue, we're immediately able to tell them, hey, we've got a fix. And that builds a lot of trust in Latch and our commitment to providing these reliable products to our customers.
Yeah, and you guys are, your devices are installed in buildings. Those locks aren't going anywhere. And so ideally you would rather just fix it with firmware. Like the number of times I've had a device replaced hardware-wise and it was just a firmware bug. Or similarly, so.
Yeah, exactly. And the cost of RMAs, right, hardware returns, is much, much higher, obviously, than just having to fix a firmware or software bug and push that upgrade out. So it saves a company a lot of money being able to resolve issues in alternative methods than just replacing hardware.
Yeah. All right.
Great. So in addition to kind of that high level holistic fleet view, we also leverage the powerful metrics dashboards to monitor dozens of aspects of our products and firmware. Our dashboards, we have many of these tiles that we look at during these reviews. And so we can easily view and analyze metrics such as product usage. Again, right? It's not just firmware, it's also product insights. So we make locks, right? One of the biggest metrics we look at is unlocking and locking doors. Right, so we can look at trends in a normalized fashion here, right? Are we seeing an uptick or change in how often our devices are being used? And we can also look at them in a different fashion in min, mean, max, where we can see, are there potential outlier devices that are getting significantly more or less use than others that may drive changes in our product, right? That we understand how users are using them better, right? And Tyler mentioned earlier, right? What is the overall success rate? So we can look at the total attempts, but we also record the successes, and we can calculate that percentage because we want to make sure that, you know, as I said, a normal key is basically 100% successful, right? And that's what we're trying to hit. And so we can see how well we are doing against that benchmark. But then we can obviously also look at, you know, kind of the hardware and firmware metrics, battery usage, or OS level metrics such as heap usage. And when we look at things like battery usage, we can see version to version, right? Are the changes we're making to improve battery life doing what we expect them to do? Not just kind of in isolation in our tests internally, but also at scale across our fleet. And we can also correlate different metrics together. I think, Tyler, you also mentioned this, is we track CPU sleep time. And so we can see how that is impacting our battery life. Obviously, those are very tightly coupled. And so we can see that and focus on areas to either increase our sleep time. We can notice, hey, some devices in particular are not sleeping very often, and surprise, surprise, the customer says they're replacing their batteries every 6 months. And so we can tie those things tightly together. And so all these insights both help us continue to improve our products, as well as verify that the changes and improvements that we're making are having the intended effect, right? When you're testing internally, you may test on 10 devices, maybe 50 devices, but when you test across 50,000 devices, you may see different behaviors when you have that level of scale in the real world. So with that in mind, I want to highlight a couple of real world examples of issues that we've used Memfault for solving. So the first one here is motor errors. So our locks will activate the motors in the device to unlock and lock the doors. And on a particular firmware version, we were reporting more failures than we expected. And so we were able to easily use this information in the context reported and provided via Memfault to root cause that issue and resolve that issue, push that update out to customers and verify that, yes, we fixed this issue at scale, right? And have that direct feedback on the changes that we are making. And this is where I also wanted to mention, Memfault is always at top of mind during our development process. And so we also use this opportunity to add in Memfault's custom data recordings to record motor current profiles so that not only do we fix the original issue, we're gaining additional insight into the behavior of our product so that we can further refine the performance in the future. And this next one is just kind of illustrating that progression from the reactive phase to the proactive and strategic phase. This example is from one of the products that we upgraded to include Memfault. And so you can see at the top here, our previous observability, we had some, it was somewhat limited. And so for an assert, for example, we just send up to our infrastructure information such as the Git hash and the program counter and link register, which definitely gives us more information than nothing. We can kind of get a line and file number from there, but that's not always enough, right, to solve the issue. And so in this particular example, it was not. And so if we transition and look over to the core dumps that we get in Memfault, hopefully you can see if it's a little too small, I apologize. But the issue stuck out like a sore thumb here in that we had unintentionally started multiple IP stack threads, right? That was causing the issue. This is something that would not have been apparent given the previous observability. And so you can imagine, right, this took us about 15 minutes to figure out the issue instead of, having to go through and reproduce the issue and try and catch the issue and take, days or longer to resolve that issue. So I really hope this overview of Latch's usage and our experience with Memfault gives you all some better insight into the platform and how it may benefit your company and products. So thank you all again for your time. And, I think we're probably ready for some questions.
Yeah, I have a couple more comments. Like the stark contrast between having to reproduce at your desk versus solving it in 15 minutes because it stuck out like a sore thumb. Crazy.
Yeah. Yeah, I'd say this is, it's one of the core and basic features, but it's probably one of my favorite features is just the core. I mean, when I think back on all the time I have spent in the past debugging issues like this, right? I'm just like, it almost makes me want to cry how much time I've spent that I didn't have to spend, right? If we had tools like this, 10 years ago.
Yeah, and then I'm glad you're doing this. Share the word a little bit to other people as well. Don't be ripping your eyes out now. There are better ways to do it. The other thing I wanted to comment on is like, you say Memfault is now part of your kind of release process. It's more of a checklist. Like, how are we going to monitor this in Memfault? How often are you seeing your own kind of developers verifying their fixes in the field with a metric, for instance? Like, I'm going to try to fix this thing. How often are your firmware engineers going into the dashboards and checking out their own metric that they just added, or maybe the one that they're trying to fix?
I mean, I think all the time, right? I mean, I probably look at Memfault every single day, right? And I think many of our engineers do that, particularly in your example during development, right? Is we are getting that insight of our fixes through Memfault, right? We definitely have things, the lower level first steps of unit testing and all that, but making sure that our fixes are going to show up in the field, right? Because if we see this internally, hey, we can observe this fix is making a change. We know we're going to be able to observe that in the field as well.
Yeah, I strongly feel that some of the best firmware engineers I've worked with in the past are very good at SQL. They know how to get data through some method into a data warehouse, and then they know how to be able to query that data. But I guess having Memfault in a lot of these cases like removes the need for that, and most people can just get the data and look at the data very easily, which is awesome. So.
Absolutely. It lets us focus on what's right. While I agree that, many firmware engineers may know SQL and that makes them better at their jobs. Many don't, right? I personally am still probably a newbie when it comes to SQL. So this allows me to really focus on what matters, right? I don't need to become a data engineer in order to gain these insights.
Exactly. Yeah. As Dave said, thank you all for joining. We have plenty of time for questions. We were happy to give this webinar. A few more things here. So definitely Latch.com is their website. Memfault.com is ours. You can look at the case study that we actually did with Latch a bit ago and look more into the use case of how they were solving a lot of their real world problems. And if you want to learn about firmware best practices, we spend a lot of time internally writing and collecting a bunch of authors for interrupt.memfault.com. I'm assuming the Latch engineers also read interrupt.com or interrupt.memfault.com. Yeah, a lot of them are heavy readers. And so now let's do some Q&A. I think Mariah or Jesse, are you running this or?
We have a few questions in our channel, Tyler.
Got it. Sweet. I will look there. And then, so the first question I have, I understand that it is possible to use Memfault for embedded devices without an internet connection. Can collected data be stored on an external drive and then uploaded later? Absolutely. That's definitely one of the use cases. And also it's kind of how Latch does it as well. Their devices, so Dave said some of them are connected via Wi-Fi and some of them connected via Bluetooth to a mobile phone. That mobile phone may go on, or that person may go on vacation with their mobile phone for a couple of weeks on end, and then they come back. That device in the meantime is basically storing metrics and core dumps on external flash to then be sent up later when the actual user is back near their smart lock, and then the smart lock unspools all of its data and all gets sent to Memfault. So that is a very common use case. That is exactly kind of how we intended and how we built the product to work. Send us old data. We'll show it on the timeline and we'll show it kind of over time and be able to aggregate all of it. I guess any other additions there, Dave? You're the one who uses that use case very well, I would say.
So certainly that is how our BLE only devices work, right? And that works fantastically. Our connected devices that are connected directly to the internet, right? They obviously are able to push data much more consistently. But one thing you can imagine is devices that are having trouble connecting to the internet. We want to know what's going wrong with those devices. And if we were only to push data over the internet, we would never know, right? And that's kind of the biggest use case to some degree of debugging those connectivity issues. So in that same fashion, right, we're able to send those logs also over BLE up to our system to figure out what's going wrong, why those devices are not connected to the internet.
Believe it or not, software, has issues connected to the internet sometimes. So another question for me real quick, and then we'll pass them off to Dave, or we'll push a couple questions to you, Dave, too. Where did the Memfault SDK sit on the device, and how does the integration process look? The firmware SDK is a collection of C files for the most part. It's written in C. We feel that is the most kind of reliable way to integrate with customer code bases. It is also the most flexible. And so you can either include that into your make file, your CMake project. We also have some packages that you can include into your IDE or developer environment. So it'll just automatically include the Memfault SDK. All of those are pretty easy ways. The integration process would look relatively simple for the core dump side of things. Metrics, we have a number of out-of-the-box integrations for metrics, especially if you're using Zephyr, the Nordic ecosystem, NRF Connect, ESP-IDF, or FreeRTOS. And if you want to add your own metrics, it's just 2 lines of code. It's very easy to add. Anyone can do it. And then there's a little bit of integration between your continuous integration system and Memfault so that we can always get your symbol files pushed, because that is how you generally go from a core dump to a full stack trace, is you need those debug symbols. Integration should typically take or generally no longer than a week, especially for a seasoned engineer that knows the code base well. Dave, were you saying something there?
No, go ahead.
Got it. No worries. Yeah, and it's relatively simple. I know when we were integrating Latch, they put one of the firmware engineers on it. I think we got something up and running in about a week or so. But it can be as simple as a couple of hours, especially if you're using Nordic. The Nordic NRF Connect SDK, Zephyr, ESP IDF, all of those are very trivial integrations, I would say. All right, let's get a question for Dave in here. Let's see. Which teams at Latch are part of the Memfault data review session? That's a good one, actually.
Yeah, that's a great question. So obviously the entire firmware team or firmware teams are involved in these reviews as this data impacts us the most. We also involve the QA teams. Our QA teams are heavy users of QA of Memfault as well, right? They're monitoring the dashboards while they're testing so that, they immediately, as soon as they find something, they can, write up the issue, add any additional context that may be needed, even though we're getting most of what we need through the platform. And while the product teams are not directly involved in these reviews, as I mentioned earlier, right, we are getting product insight during these reviews that we can directly feed back to our product teams so that they can make decisions and drive change as well.
Got it. Thanks. And another question, what would be your advice for someone building a new IoT product and looking to introduce observability? How do you pick the right metrics to track?
Sure. So, I mean, I would first say start small, right? Like you mentioned, you can get up and running with Memfault very quickly, right? And I think it starts small, right? Get the SDK integrated and put in a trace, right? And I think initially, right, one way to think the right metrics is, I would imagine almost anybody that has an embedded product right now has some printfs that they're using to log things, right? So your first step can be replace some of those kind of maybe critical errors that you're logging to a console into a trace so that you can get that data remotely. Latch has been using Memfault for years now, but while we use Memfault to continually improve our products, we are also continually improving our usage of Memfault, right? And adding more and more capabilities to our tracing logging metrics as we go along and as we learn more.
Yeah, believe it or not, Memfault continues to improve as well, even without your active effort. So you have to keep up with us. And then, yeah, I guess I'm curious, are your engineers picking which metrics to track? Is that coming from, I guess, the management side of things? Is that being driven by the product team?
I would say most often the engineers are tracking these things. So while we do certainly have metrics that are geared toward product, right, and understanding usage, we as firmware engineers get the most value out of understanding the performance and the issues of the new features. So product will have input on the behavior itself of a new feature, but we will take that input and decide and determine what specific metrics we will need to record to make sure that feature is successful once we roll it out to the field. So we use our specific knowledge of our software and firmware architecture to determine what metrics and traces make the most sense to add.
Got it. This is a good one. I think the answer can go in many different ways. How do you, in Latch, balance new feature development and kind of improving what's already there, bug fixing, current health, improving battery life beyond what you expected, that sort of thing?
Sure. I mean, I think that's something, regardless, that all engineers struggle with, right? How do you prioritize, fixing things and fixing issues, right, versus providing new features, right? Your example of if the CEO is having a problem, like if he's the only one, that may not have the most impact, right? Or may not be the best thing to focus on, right? So I think a lot of it is around what is going to have the most impact on our customers and on our products, right? So if we are seeing that a particular product line is having a lot of issues, well, we may have a desire to push out a new feature. We have to balance that with the impact on current customers and the satisfaction of current customers, where we might focus more on that reliability and performance based on the data that we're getting from Memfault.
Got it. One of the and I think this, just adding a couple comments here, that maturity model chart where it's like you're going from reactive to proactive. I think without observability tools and without kind of knowing all the issues your devices are kind of getting into, I have felt in the past like drowning, drowning in so many issues, either from customer support or just the it doesn't work sort of customer support tickets, whether that's connectivity or battery life are the two most difficult ones in my opinion. And never feeling like you can get ahead of them. It's so hard to build new features when that is kind of the status quo and that is what you're going through. And it's been fun watching people kind of get through their integration into Memfault as well to feel like they're not drowning. They're like, cool, we fixed like 4 of these crashing issues that would have been the noisiest possible things if we had shipped them to production, or this was a really bad battery regression that we caught internally. We no longer have to experience that like customer support drowning of tickets. And yeah, you can, I guess, more reliably control how often you're going to be spending time on new feature development versus fixing the thing. Because if in Memfault you see that there's a battery regression, you have to go fix it. But you don't need to throw all of your engineering capacity at it. You can probably throw one engineer at it because you know it's just actually this particular issue and not just like it doesn't work. So there will still be fire drills though. But yeah, go Dave.
Yeah, absolutely. And I think having this data and having this context again helps you prioritize and debug issues. You know, for example, right, we may see something that looks like an issue for connectivity, for example, right? We have our locks installed across thousands of buildings, right, if you will. And as you can imagine, it's all different types of environments, all different types of networks that are outside of our control, right? And so having all this data can really help us be like, well, all the locks at this one building, right, that may have 100 locks are offline, right? And that may impact our overall metric, but having that full picture, we can be like, well, their network is likely just down. The chances of a firmware issue causing only locks at one building to be down is very low, right? If we have a true firmware issue around connectivity, we're going to see that across the fleet. And so we're able to kind of narrow in using the data on issues like that and just say, hey, that's not really an issue we need to concern ourselves with.
Yeah. Awesome. One more question from my side, and then I may pass it off to you, Dave, just to explain it a little bit. What is your experience with customers opening up their network to get the data to Memfault? I would say this has generally not been too difficult. I would say like getting the data to Memfault is a one-way connection. Devices pushing data is generally not a huge network concern. It is when services go down into the devices kind of as the first step. That is where firewalls will block sort of every device connection. But these devices generally push data to Memfault. There is no, it's only one directional in that way. The other thing that we do for Memfault is package up the data in either what we call chunks or we call MAR files, basically Memfault archives. With chunks and Memfault archives, the data is just kind of opaque packets. As long as those packets or pieces of data make it back to Memfault in whatever order you want to send it, basically, we will be able to reconstruct the data. And so we have a lot of customers, including Latch, that kind of passes this data through AWS. And then either in a Lambda function or some other sort of software that they've written, they will forward those over to Memfault, and it will stay inside of their cloud. It will stay on their like internally encrypted and secure connection. And then once it's in the cloud, they will pass it off to Memfault. And I was going to have you just elaborate on that sort of, Dave. Like you had that set up in AWS where like it's a Lambda function.
Yeah, that for our internet connected devices, that's exactly how it works. And so we haven't really had any issues with customers opening up their network. And I think often a connected device, right? Your device is already relying on some sort of internet connectivity and that pathway to the cloud anyway. So for example, on our devices, right, we are already using AWS as a communication channel for our own purposes, right? So adding Memfault to that pathway to get up to the Lambda function and then to Memfault didn't require anything additional to be opened up by our customers. So there's no real, we haven't experienced any issues there. And then obviously in the BLE case, right, it's completely outside of the customer's network and connectivity. So yeah, we haven't experienced any issues on that.
Got it. Awesome. There's a question about traces. What are you guys using traces for? Like, what are your main use cases for traces?
Yeah, I mean, we try, and this is something that we kind of refine over time, right? And in particular, right, our newer products that we backported, right, we're currently refining that now, right? But our products that are more mature with Memfault have refined those traces, and often where we are try to be diligent is getting traces for issues that will actually impact the behavior or performance of the product, and that especially that the customer may observe symptoms for, right? And so often I think this is the difference between kind of, you know, printf debugging, if you will, and kind of adding traces to Memfault is we don't necessarily want to flood the system with informational traces, right? We want to know what's going wrong, right? And we can get a little bit more information and context leading up to those specific issues using our compact logging and whatnot, right? To get a little bit more of just that debug information, but we try to stick to what are the most impactful errors that are occurring that we want to see traces for.
Got it. Yeah, traces, you can think of them as like just a event of sorts. Like this event took place, it was this type of issue, here's some context around it. And then at Latch, at Latch, you're counting them a lot. You're basically saying, is this number trending up or down? Is it per device counts trending up or down? And it also just helps paint a picture for customer support. Oh, yeah, this thing has happened 10 times in the last week. It is at least, well, maybe not a new issue, but also that's weird that it's, you know, happening 10 times. So let's go look into that. So, I have one selfish question, and then we have to wrap up because we're just over time as of right now. When you ship a firmware update, like how well do you sleep at night with all the data flowing into Memfault?
I mean, I think we sleep generally well. Like I mentioned, you know, we focus so much on gathering all this data in the development and QA phases that we feel like we know what to expect when we release that firmware release, right? Even if there are issues, right, that we've decided are low impact issues, we have a good picture of the performance of our products with all this observability in place. So by shifting all of that, you know, left in our process to the development and test and debug phases, right, by the time we get to production, we feel like we have a pretty good idea of what things are going to look like. Obviously, things happen, right, and we'll notice things, but again, right, we'll pick up on them very quickly, and they're able to react very quickly for any of those unknowns, particularly that may be noticed when you're doing this at scale rather than kind of the smaller internal numbers.
Yeah, awesome. So great to hear. The numbers just scale up when you go to production. There's not many new surprises, basically, or at least usually. So, yeah. All right, that is all the time we have, or all the time we have. Thank you, Dave, seriously, for joining us today. Love the conversation. Love hearing about Latch's story.